You were thinking it. I'm not a liar. Rhiannon, shout out to our missing people.
All right, so Justine Nelson probably won't watch the video because she's a slacker, and then I almost said Justine again, and then Jared won't because he's a slacker, and then who else is gone? Terry will because I love Teresa, and Braden's gone, but that's okay, and so is Travis, and that's perfectly fine too. And Jens, well, skip Jens, and then what's that one? And Jake Ware's gone too. Jake from State Farm. I'm sorry, Jake. Oh, and Lolly, I love you. Okay, bye.
All right, wow. Okay, got to give everybody a chance to talk in class, and that's what we do. So today is going to be pretty straightforward. You already know how to multiply, add, and subtract polynomials, but let's learn how to divide them. And we're going to do long division. We'll take x plus 2 and divide it into 3x plus 6. So we use that long division symbol. And the question we ask is, what do we multiply the first term by in order to get the first term underneath the division sign? We multiply by 3. And we place that 3, we place it right above the constant. So we order those terms together. Does that make sense? Then we multiply 3 back through, we get a 3x plus 6. And when you subtract, you get 0. So the remainder is 0. You all good with that? All right, we try B. I have x minus 2, and that's going to go into x cubed plus 0x squared minus 6x plus 4. Why? Because you have to have a placeholder. You're like, well, I don't like that. Well, you do. Like, if you're supposed to get a check for $107, you're glad that they don't give you a check for $17. You like the placeholder when they're giving you money, right? Are you okay? Yes, I know very well. I was going to delay that for about another 3 minutes, but we'll get to it sooner. So anyway, we've got x times what is x to the third? We got x squared. And then we multiply through by x squared, and we get x cubed. Why is this x squared? Because you have to ask yourself the question, what do I multiply this term by in order to get this term? We good now? So I have 0 minus negative 2x squared, and I get, very good, positive 2x squared minus 6x. 0 minus negative 2. Now what I'll do is I'm going to look at, and notice I have a binomial here. If I had a trinomial up front, I'd have to bring down 2 terms. So, yep, I multiply by 2x, so positive 2x. Notice that my x term is above the linear terms. 2x times x is 2x squared minus 12x. I subtract. What am I doing? I'm just making stuff up. I'm just making it up. Okay. Okay, so negative 6x minus the negative 4x will be negative 2x, and then we drop down the 4. What do you multiply x by to get negative 2x? Negative 2, and so we get a negative 2x plus 4, and when we subtract, we get 0. Pause. Time out. Ice is back with a brand new invention. Grabs a hold of me tightly, flows like a harpoon daily and nightly. Will I ever stop? Yo, I don't know. Turn off the lights and I'll glow. Jump on the stage. Rock the mic like a candle. Vandal, whatever. Okay, what do you got? Right here? So 0 minus negative 2 is positive 2. We got it? All right. Amen, brother. All right. Look at my remainder. My remainder is 0. Can I teach you something awesome? Because you don't get a calculator on this test, do you? And does he pay attention in class? Okay. All right. So here's what we're going to do. I will teach you the remainder theorem, and the remainder theorem is awesome, and it says this. If you take the solution of the divisor, which is 2, and plug it into the polynomial, you will learn what the remainder is. What's 2 to the third? 8 minus 12 plus 4 gives us 0. That's my remainder. So that way you could check to see if you did the long division correctly. Let's apply that and see if we can do it. Flip it over. We'll do D before we do C. Very good. But it's a free country. What is the solution to the divisor? 1. So if I plug in 1, I get 1 minus 4 plus 2. 1 minus 4 plus 2 is negative 1. So that means that the remainder should be negative 1 when all is said and done. So I'll divide that. X minus 1 goes into x to the 4th minus or plus 0x cubed minus 4x squared plus 0x plus dose. 2. What do you multiply x by to get x to the 4th? X cubed. You get x cubed for x to the 4th minus x cubed. 0x cubed minus negative x cubed. Positive x cubed, I drop down the next term. X squared. Hi! Tell her to do her own dirty work. Negative 4x squared minus a negative x squared. Very good. Negative 3x squared. I'll drop down the 0x. What do you multiply negative 3x squared by, or x by to get negative 3x squared? Negative 3x. I subtract. Negative 3x. Two minus 3, negative 1. That's my remainder. Did I expect that as a remainder? Yes. Now let's just back up a little bit to 3rd grade, 4th grade, whatever. If you took 7 divided by 3, you wrote that as 2 with a remainder of 1. And then you started to do big boy mathematics, and you wrote it as 2 and 1/3, correct? Yes? So you took your remainder and you put it over your divisor. So you'll write this as minus 1 over x minus 1. Your remainder over your divisor. How's that? All good? Okay. For the sake of just making this just a little bit easier, because I'm tired of doing this example, it doesn't work out very well. Let's change it from 2x plus 1. Let's change it to x plus 2. Why don't you go ahead and try letter C on your own and just do x plus 2. Okay. So for YouTube Nation, I just did the remainder theorem. I see you should come up with 6. And can somebody tell me what their final answer looked like? Very good. So again, it's easy to check to see if you have the correct remainder, and I'll generally tell you you hopefully did the problem correctly. So let's move along. I don't like long division. I would rather divide using synthetic division. So this is where I do not match up with my peer, Miss Nelson, in terms of how I teach it. I like to organize it just slightly different. Sometimes she does. I'll see. I'll see. She gets tired of my voice, so. All right, okay. Let's plug in a 1. 1 is what you would have for a solution to your divisor, right? And so what we're going to do with that is we're going to put that here, and I put a half box around it. You're going to be doing the same thing you did last year. I like to organize my work like this better. So. And then I put the coefficients up top, 1, -4, 2, and 1. And I put a half box there for my remainder. If you know it a different way, you can do it a different way. This is the way I do it. And we simply just drop down the very first number. And then we multiply and add. 1 times 1, add, multiply, add, multiply, add. If you plugged in 1, we would get 1 minus 4 plus 2 plus 1, which is 0, correct? So it's what we get when we plug it in. And you can see that we should get a remainder of 0. Yep. I take the 1 times the -3 to get the -3. I add to get -1. I multiply the 1 by the -1 to get -1, and I add. And so now this is my remainder. So that means this is my constant, this is my x, and this is my x squared. So I have 1x squared minus 3x minus 1 with no remainder. So all of a sudden, long division became very quick using synthetic division. What number do I put up in my box? My coefficients are 4, 8, 0, and so again, constant x, x squared, x to the third. So I have a 4x cubed, I have a plus 4, and I have a minus 15 over x plus 2. So as you write your final answer, again, you're going to want to write the remainder over your divisor. What's different about letter C? Very good. 1/4 is going to be the number that I put up there in that box. Got a 4, a -8, a 12, and a 3. I drop the 4. What's -7 times 1/4? -7 over 4. 12 plus -7/4. Oh no, I got to find common denominators. So I've got 48 over 4, and -7 over 4 will make 41 over 4. 1/4 times 41 over 4. 41 over 16. 3 plus 41 over 16. So 48 over 16 plus 41 over 16. 89 over 16. So I have 4x squared minus 7x plus 41. 41 over 4 plus 89. If I wrote 89 over 16 over 4x minus 1 would be a complex fraction, wouldn't it? Just the 16 and the 4x minus 1, they just go together down in the denominator. If you were to simplify and multiply by the reciprocal, that's what you would get. So. You try D on your own. You all good? Did anybody make a mistake they would like to share? Which, okay. All right, for the YouTube Nation, one of our students hasn't made any mistakes in their work, but they don't know where we're getting the numbers. So this is, don't know how that works. I haven't, so what? You tell, like, which number? -5 times -1. Got it now? Okay. All right. So synthetic division is awesome. But the question is, what is it really useful for? I mean, in mathematics, we don't like to simply just perform operations for the sake of performing operations, right? I mean, factoring is cool if you're finding solutions to x-intercepts. But factoring on its own, it's like, what use does it, really have? And so you're going to see why we use synthetic division. And so you got to kind of stick with me for about 2 minutes here to see the reason behind this theory. But the rational roots theorem, I think, is one of the coolest things that we have in mathematics, especially in algebra, at least. It's really awesome. So as you look at this factored two binomials here, I'm going to multiply it out. And what do I get? 12x squared, 23x. Great. So if I were to set that equal to 0 and I wanted to solve it, we know how to factor that, right? I mean, the factored form is sitting right above there. But suppose we didn't know how to factor it, okay? You would you do the AC method, you quadratic formula, whatever. You do guess and check. At the end of the day, look what's really interesting here. Try to understand why this is as cool as it is. What is our solution here? -2/3. What is our solution here? -5/4. Well, what's really interesting is if you look at the factors of 10, 1, 2, 5, and 10, if you look at factors of 12, 1, 2, 3, 4, 6, and 12, the numbers on the top, -5 and -2, they come from the last number. And the numbers on the bottom, 4 and 3, they come from the factors of the front number. And so we like to call the factors at the end the p's, and the factors at the beginning the q's. And so the solutions are plus or minus the p's over the q's. Remember that? A little bit? So trust me, when we do 3 examples of this, you'll feel better about it. But here's the theorem. This is the rational roots theorem. And it says, let p of x be a polynomial of this form. And the really important thing to pay attention to is the a sub n up front. That's your front coefficient. And then a sub 0, that's your constant at the end. And this fancy terms for x to the nth and the x to the n minus 1, it just means it's being written in descending order. So like x to the 5th, x to the 4th, x to the 3rd, so on and so forth. And here's what we say. A sub n has factors of q, and a sub 0 has factors of p. If the polynomial has any rational roots, and when we say rational, we mean like -3/5. We don't mean the cubed root of 29. We don't mean the square root of 15, and we don't mean 3 plus I roots of 2. Those are not rational, but -3/5 is. If it has solutions that are rational, they are of the form plus or minus p over q. So flip it over. Let's try 3 examples, and it's beautiful. You guys saw a nice introduction to the rational roots theorem last year. We're going to use the rational roots theorem and the fundamental theorem of algebra to we're going to put it on steroids this year. Okay, it's going to be awesome. You're going to love it. I should not be condoning steroid use. Well, just look at me. Do I look like I'm on steroids? I mean, okay, all right, whatever. Okay. Zach, you're not even laughing. She is. Okay. The degree is 3, and as I look at it, is that something that factors x to the 3rd minus 7x minus 6? No, we can't see it factoring. And so, therefore, we resort to the rational roots theorem. And it says find the p's. Find the q's. What are factors of 6? 1. What are factors of q? So our choices for what we think might be solutions are our p's divided by our q's. Plus or minus. So I take all of my p's and I divide by each of my q's. What are some of my results? Yep, plus or minus 6. Those are my choices. I got some good guesses. And thankfully, because I taught you the remainder theorem, we know that we can simply just plug in these guesses. And we're waiting for one that has a remainder of 0. So let's try plugging in 1. I get 1 minus 7 minus 6 is negative 12. Oh, sad face. Doesn't work. Okay. We'll leave that out. Okay, let's plug in negative 1. Negative 1 will give us negative 1 plus 7 minus 6 is 0. All right. Negative 1 works, right? Hey, if negative 1 works, then what is the factor that divides in evenly? What is the binomial factor that divides in evenly? If negative 1 is a solution, what's the binomial factor? X plus 1. Now that we've found one, let's divide it by that factor. I drop the 1. Negative 1 times 1. So here's the cool part. This thing right here, x to the third minus 7x minus 6, it actually does factor. It factors to x plus 1 times x squared minus x minus 6. That's what it factors to. Does the x squared minus x minus 6 factor? Yeah, it factors to x plus 1 times x minus 3 times x plus 2. So it turns out it does factor after all. And now we can list the solutions. X is equal to negative 1, negative 2, and positive 3. And what's great about that is if you look within your choices, they're all sitting there. Okay, Michael said, 3 is going to work. Yes, it does. And you can look and see that all of your, solutions end up being one of your choices, correct? So, degree 3, we should have 3 solutions. Okay. Trust me, you'll get really, really good at it. Again, one of the highest scoring tests of the year. Yes, you did this. We're going to do a little bit more with it, okay? Trust me. You'll see some things that you do not yet know. What's the degree? Do you see a way that it factors? Because I don't. So we check out our P's and we check out our Q's. Yep, 1, 2, and 4. Q's are 1. So what are my choices? Awesome. What do you want to plug in first? 1. 1 plus 3 minus 4 is 0. Smiley face. Awesome. If 1 works, then what's the factor? X minus 1. So I take the 1 and I divide it in. So it turns out that it does factor. We just couldn't see it. It factors to x minus 1 times x squared plus 4x plus 4. Does that factor? So what are my solutions? negative 2, and 1. You have to write the negative 2 twice or list it as a multiplicity of 2. Not too bad, huh? Well, we had no idea how to solve that before, trying the rational roots theorem. Works out pretty cool. Ooh, so you're looking at number 3, and you're saying, ick, Mr. Gantz, you're a jerk. You said we can't use our calculator. Now you're going to do this. Trust me, I said this will be the highest scoring test of the year. Trust me. Degree 3. P's. 1 and 3. Q's. So my choices. Good. 1, 1/2. 3. 3/2. So what I'm doing is I'm taking each one of the P's and I'm dividing by each one of the Q's. So 1 over 1, 1 over 2. 3 over 1, 3 over 2. Oh. Let's plug in 1. I say that's a bad choice. Why? And they're all positive. I mean, just think about it. Is a positive number going to work here? It's got to come out to be 0. You need a negative somewhere, don't you? So let's try negative 1. You had negative 2 plus 9 minus 10 plus 3. No, it's okay, Rhiannon. I'm glad you said it because at the end of the day, we are going to talk about what are some good choices and bad choices, but that's going to be later on. Okay, so I get 0. Awesome. So negative 1 works. So what's my factor? X plus 1 is my factor. So I'm going to take negative 1, divide it into these coefficients. Does 2x squared plus 7x plus 3 factor? Yes, it does. So 2x and x. And what are we going to have? So what are my solutions? So my good friend Maddie talked about the fractions, and I would agree that I don't really like to plug in fractions. The nice thing is that did I have to plug in negative 1/2? No, once I got one of the integers to work out, I was able to figure out the negative 1/2 through factoring. You can also see that negative 1/2, negative 3, and negative 1 are all choices, and that they are all negative. So the reason why I'm doing this, you guys, is because we're going to add more stuff to this, and it's really going to help you confirm your answer. So get used to looking back. Flip to the very last page of your notes, very last page. Now, you don't have to do this. You don't have to read through this every time. I just want to walk through it with you once so you understand just a little bit of what should be up in your brain, okay? And this is the idea. We first started by identifying the number of roots. And the last problem we did, how many solutions were there? There were 3. We asked ourselves, did it factor? If it does factor, you guys, please factor it. Factoring is a great option, and it gives you a lot of solutions, whether you're using grouping or sum of 2 cubes or whatever it is. But if it doesn't factor, then we don't really have an option other than using rational roots theorem. You identify your P's and your Q's. You use the remainder theorem or the substitution in order to see if it works. Once you find it, you divide. But here's where it's interesting. Notice that all the polynomials we came up with were of degree 2. When you come up with a squared, you can either factor it or use a quadratic formula. But suppose we started with an x to the 4th. We would end up with an x to the 3rd when we divided it. If that's the case, if the degree is greater than 2, then you got to start over and go through the process again. Now, we're going to have some ways to show you in which that's going to be quicker, but tomorrow you can see that from our, from our remaining problems. Tomorrow we got this x to the 3rd one, but then on the next page, we're going to step up the degree just a little bit. Oh, I got to find one that doesn't have calculus on. X to the fourth. You know, what happens when we step the degree up a little bit? We have to do it more than once. And trust me, you'll get really, really good at it. Trust me. So, rational roots theorem, you're getting an assignment today. You do not have an assignment tomorrow. So, tomorrow we are going to finish off the notes, and that will be the assignment. 5 through 27, the odd, and then 28 through 31. The question was from last hour was, will we be able to do all of the problems? Just about, you know, anything that has a anything that's to the third degree, you'd be able to do. So you'd be able to knock off a lot of those problems tonight. And to all the people who are in the play, break a leg. Musical. Own it. Who's going to see it? I'm going Friday. Rachel, when are you going? Thursday? Gina? Friday? See you there. Yo. Oh, my broad shoulders are in the way again. I'm sorry.
Wait, can I say bye?
Yes. Brianna would like to say bye.
I miss you, Justine. Please stop getting involved in so many things, you good egg, you. Okay, bye. Good luck. I love you. Bye.
Peace out.
Oh, wait, Brenda!
Brenda's not going to watch this.